All right, so I would like to welcome you to our electric vehicle, and we are here at the Jamaican German Automotive School, where we have two electric vehicles in our workshop, and they are from BYD. And this one right here is a luxury electric vehicle, and this one here on the left, this one right here is for commercial application. As you can see, this electrical vehicle right here, share the same chassis platform with its Nissan counterpart. So basically, BYD just put in the powertrain, but the shell of the vehicle, the chassis of the vehicle is actually Nissan. Alright, so for this electrical vehicle, it rides on the lift and we can look. If we should look right here, we would see our suspension system is similar to is the same to our gas counterpart, where we have the control arm, we have the CV joint boot, we have the tie rod end, the rock end, we have the stabilizer bar linkage, we would have the shock absorber up there, and with the strut mount. And so the chassis platform is technically the same. But when we should look now on the powertrain, which is the main difference, here we have two cables. And these two cables, they will send power and receive power from the battery. Right here, our battery pack is right here. These two hoses actually send coolant to this battery pack right here. This battery pack. So this battery pack right here is actually a heat exchanger and a battery module integrated into one. So basically we have to cool all of this battery right here. And Nissan have learned from their Nissan Leaf, where they actually use air cool. But for this system, to maintain the longevity of the system in the tropical climate, they tend to cool it with liquid. Alright, if we should look on the back right here, we'd see our conventional leaf spring. And here we have our shock absorber. What is unique with this particular system, that we have an E-part brake. And if we should look close right here, we would see our actuator. So this is our caliper actuator that activates the electronic part brake, the E-part brake. But as you can see, here we have the backing plate. We will still use the conventional disc and brake. So it still carries a disc brake and a hydraulic caliper, but however for emergency brake we have an E-part brake. At the back right here, we still have our spare. So when you compare the electric vehicle, the battery electric vehicle, with our conventional gasoline vehicle, the only thing that is different is really the powertrain, which just consists of the battery and those electrical motor. When the vehicle come down, we will take a look on these components. Alright, so here we are under the bonnet of the vehicle, and let us see the things we can get ourselves familiar with. Alright, if you should look in that corner right there, we have the shock tower and the strut mount. Front end still remain the same. Alright, what we are looking at now, we are looking at some reservoir. This is a reservoir, this is a reservoir, this is a reservoir. Alright, remember I showed you the E-part brake earlier, the caliper actuator. This hydraulic fluid will still operate the conventional hydraulic brake. And there it is. We have the vacuum booster. To get a better shot, we have the vacuum booster right there, we have the reservoir right there. So yes, if the electronic should fail, the conventional system will still work. And if you notice on the booster line here, we have a sensor. This sensor, that 3-wire, anytime you see 3-wire, have to be pressure in power, grounds and signal. So this sensor is actually the booster pressure sensor. Alright. So, and of course I'm searching for the ABS modulator. and it is right here. So here is the ABS modulator. Alright? So where we have the vacuum booster, master cylinder, the ABS modulator. So I'm saying that to say this, the conventional ABS system will work and the hydraulic braking system will work. However, it's e-park brake. So here we have our normal 12 voltage battery. The purpose of this battery is to operate things like the headlamp, high beam, low beam, the dome light, the accessories and those things. However, this vehicle is built with a DC to DC converter, which we would have approximately about 360 voltage, can be more or less, but 360 voltage to operate the high power system. Then we'll have the 12 voltage. Alright, this component that we are looking at now is our inverter converter. It's actually really converter, because this inverter converter now, these two orange cable, they supply voltage to the battery. So voltage to the battery can supply to the voltage to the battery can supply by two means. It can supply either by charging the battery. That means we would plug it into a stage 1, stage 2 or stage 3 charger, or voltage can supply to the battery by the method of regenerative braking system. Alright, so therefore if you're going down the hill or you're barely touching on the brake, electricity can actually produce within the regenerative braking system. So this orange cable right here and this orange cable around here, you notice them? Those are those high voltage cables. So this inverter converter now, it will take the battery voltage, which is DC, and it will convert it into AC and supply it to the AC electrical motor. Within this inverter converter is a frequency controller, because all the speed of this motor change is by frequency and not necessarily by voltage like we have in the DC. So it is a frequency controller and also a voltage regulator controller. This inverter converter, I'm trying, alright, and if you should look right here, I would assume that where I'm seeing that red plus, it would be a 12 voltage. I am looking for, alright, good. So this is where the cooling of this inverter take place. So if we should look on these two reservoirs now, these two reservoirs, one would be for the motor, dedicated to the motor, because the motor needs to be cool. Within the stator of the motor, you would have water jackets or water passage, just like our internal combustion engine. So one of these reservoirs will dedicate to cool the motor. The next one of these reservoirs will dedicate it to cool the battery. So therefore, we would have two electronic control water pump. I don't know if I can find them right here. Once I can find the hose, I'm supposed to be able to find them. Alright, so this reservoir right here will supply the motor, which is under the inverter converter, because this is the inverter converter. So the motor will be right here. So here are these two hoses. So this supply the motor with coolant. Alright, and even if you should look on the hose, it will show you line of direction. So for people who are doing cooling system, this will be something for you to study and have to understand. Hose will deteriorate after a while, coolant will have to change, flushing will have to take place. Alright, so this reservoir, it supplies coolant to the electrical motor. So therefore, this reservoir now would supply coolant to the battery that I showed you underneath earlier. Alright, this component right here, I'm not too sure what it is, but I would say it is a DC to DC converter, because as you can see, I'm seeing some orange wire. Once I see the orange wire, it means high voltage. I'm seeing orange wire going to this module right here, and I'm seeing some smaller wire coming out. The size of these wire or these conductor, the current cannot be high. So most likely, in my opinion, I could use a multimeter to confirm it. This is taking some high DC voltage and it is cutting it down so it can supply accessories and also charge the 12 voltage battery. Alright, we're also seeing our AC pipes, because this vehicle needs to be cool with AC also. Still searching. And a matter of fact, soon come to that. A matter of fact, if you should look right here, we'd see this hose right here go straight down to electrical motor and come up back. So alright, to know that the motor cool, the inverter cool, we have the DC to DC converter. The AC now. The AC compressor is driven by electrical motor. Aha, here it is. So here we have the AC pipe and here is the electrical compressor. So this compressor right here is driven by electrical motor, and this ensure the vehicle to cool.
So the AC, what AC you're now?
Electrical motor, which is right down there. Yes, right down there. Alright. And if we should look back here, this is a fuse box. See, it will still have our fuse box because we'll need it for the accessories. Those two hoses. Yes, it carry a heater core. So this particular system, it don't use a electronic heater core. It actually carry hot coolant to the heater core that is underneath the dashboard, so to provide heat for the passenger compartment, because Tesla suffers significantly from keeping the vehicle warm during the winter time. So I guess that Nissan BYD learned from that and revert to the heater core system. Alright, this now, the AC, as we can see, AC pipe go to right here, so this have to do with the AC. I'm seeing a pump right here, which is this. I'm seeing a pump. That is a water pump. See it right there? That is a water pump, but I'm not sure exactly where it rolled to. But if you're working on this vehicle, what you can do, you can basically trace the hoses where they are from, if it is coming from the inverter, coming from the motor, and you can find back the water pump, find back the reservoir, and find back all the things. So pertaining to this system and gasoline system, we're going to do some work. What are the work we're going to really do different? Pertaining to the electrical powertrain, the only thing I see we'll be doing in the future is just changing coolant. If your inverter become defective, of course, that will have to be replaced. If your electrical motor become defective, that will have to be replaced. But once our cooling system is working properly, these things most likely will last anywhere from probably 10 to 15 years with ease, because electronic things don't feel like that. However, our hoses, if you keep the vehicle beyond 5 years, you know that our hose will be crystallized. So things like our hose will get defective, things like our electrical water pump will get defective, and I am sure based on the geometric layout of the inverter and the motor and the battery cooler, we know that some bleeding will have to take place. The bleeding procedure for this particular system, I don't know, but I guess information will be in the manual or online, or if you don't have none of that, you just hunt the system and look anywhere see some screw, you take time, pull them off, any coolant coming from them, you bleed it from right there. So because this system will must have to bleed, because if it don't bleed, it will be detrimental. Alright, but our braking system, technical repair and this part, rotor, this will have to be changed. Adjust cooling system, we'll have to flush our system. We'll have to change our hose. Our battery terminal we still have to clean. Battery strap will still have to be dealt with. And I'm seeing some ground strap on this vehicle right here, and I'm kind of confused. Reason being, I know that this is a high voltage system, but the ground strap normally dedicated to the 12 voltage system. So when I get more technical literature on that particular system, I will make another video about that. But so far, our electric vehicle, the work is still there for automotive technician. We'll still have to work with, still have to repair steering system, suspension system, braking system. We'll still have to repair body panel. We will have to drain our coolant. We will have to change our tires. So it is not all doom and gloom. Sir, excuse me. Can open the for me. Alright, so here we are. And here we are, we actually have pedal. So this will be the accelerator pedal and the brake pedal. Still have our steering shaft And look here, people. The diagnostic port is an OBD2 port. So for this electrical vehicle, does not require no emission standard because all motors and battery don't use gasoline, battery electric, but we still conform with the OBD2 diagnostic port. So our scan tool will be able to go in there. We still have a start, stop button. Here, this is different from the other BYD. Our gear stick right here. So we still have the park, reverse, neutral, drive, and we still have zero. Again, zero is neutral, or zero neutral is the same thing. Here we have our e-park brake. So this park brake is what activates those electronic caliper at the back. Alright. This is a 12 voltage power outlet. Right here. I think this might be some USB port. For commercial application, seats are pretty comfortable. Alright, let us look right here. Our temperature AC system, just like our conventional system. Our infotainment system, our dash right here. It's basic BYD. Our airbag, our cluster. Excuse me, I have the light. Could I turn on the cluster? Okay. If I could have turned on the ignition, I could see the cluster.
Press on the brake.
Brake.
Press the button.
Start. That's one time.
Yeah.
And it's in park, so it will not. It's in neutral now.
Yeah, man, it's park.
And the park brake engage.
Yeah, start.
Alright, good. So, why am I hearing that sound?
Because the doors are open and the bodies are around it, so it's
Oh, so it has sensor, proximity sensor.
Yeah.
Oh, so this equipped with proximity sensor. So, alright, park brake engage, the kilometer, 180 kilometer. This is technically 0. So, that green means fully charged, right?
No, because the percent of the charge, you know.
So it's actually 87% charge. I wish turn off the indicator for this.
The indicator.
Alright. Park brake, okay. The door is open. Alright, I'm gonna switch it off back. So most of those things in our cluster. So technically this is our electric vehicle. So we as motor vehicle technician will still have work to do. A lot of work to do, especially for commercial vehicle applications. So hopefully next time when I'm making a video, we can actually do some pulling up and changing of battery. But this particular system, the battery module cannot be changed. If the battery is defective, we just have to replace it. So that's it for me, and thank you for watching the video. Bye.